So I think we should start. Before I start, I want to say something about the mean thing, because some of you sent me the email asking me whether we have midterm in our course. Just make sure that there's no midterm. There's no midterm test for our class. And there indeed a final test, which will be held, as I said, it will be held on the last Friday of the semester. It will be evening. Exact time will be determined after the drop period. I'll send out a Google form so that give you a few choices, then you can tell me which one would best fit your case. So please mark down in your calendar. But probably maybe either the choice with 5 to 6, 6 to 7, or 7 to 8 will be 1 hour test. But I will send out the thing after the airdrop period is over. Second thing is some of you indeed asked me at the end of the slide, there's a link to the recorded lecture. There is a PDF file that contains all the link to the lecture. It was recorded 2 years ago, but I think there would not be any issue. I mean, you can check out if you are not sure what is going on. So if there's no question, then we will talk about, we'll finish the descriptive statistics today. So I think last time we basically cover almost everything for the free representation, mean, median, mode, range, interquartile range, variance, standard deviation, coefficient of variation, kurtosis and skewness. Let us quickly remind you what's going on, all the formula, and then we will go to the next thing. We'll study how two variables are related. Okay. And let's quickly go back. The mean is sum of all the observation over the number of observation, which the meaning of it is the distance in the middle. Okay. And the same as your old slide, just add a page because I saw many of you have drawn the diagram. So basically just like the mean is the middle. Okay, there's a 4 data point here, and to the left is a red area, to the right is the blue area. It means the blue distance and the black distance will be equalized when the mean is there. But other than that, there's nothing new there. But that's the meaning of the mean. And as one of the problem of having mean is an outlier would change the mean substantially, as we can see from the example here. So one way there are 2 ways to do it, is either trimming or winsorizing. Okay, and they are related to the simple mean will be the weighted mean. You put different observation of different mean, different weighting. And there are other type of mean like geometric mean and harmonic mean that have different purpose and different usage. And the next is median. And median is exactly the middle guy. And we do know that this middle guy exists explicitly when the number of observations is odd, because that's an exact middle guy. If no, that would be just average of 2. So that would be the formula, and the formula is given by this rather technical one, but it will be useful if you really want to write program. That would be the thing you need. And the median is exactly the regard of distance, so it's exactly the center. Okay, so that is the meaning of that. And the next one is mode. Mode will be the most frequent observation. And do note there will be some important difference when you have this and others. Is in some of the books they will define if you have each observation only appear once. Okay, they said there's no mode. I think to be consistent, I think it would be good to have still constant mode. So that is our purpose. Okay, so that is a main difference between our definition we use compared to others. I think that one is more appropriate because the definition when you have 1 is different from 2, that would be a issue, right? Because if you're 1, 2, 3, 4, and then 1, 2, 3, 4 again, you have eight observations, each one appear twice, then you have everything is mode. But when it appear once, there's no mode, then it's not very natural. But anyway, shouldn't be an issue for us. And there are 5 measures of dispersion: range, IQR, variance, SD, and CV. The easiest is to look at the to put in a box plot, right? And it's just the maximum and the minimum, and the middle is median, right? And the Q1 will be the median of the first half, Q3 will be median of the second half, right? And the main difficulties is when we have a small number of data, small number of observations, how to define Q1 and Q3 will be an issue. Median is never an issue. The problem is, say, method 1, method 2 is whether you include the median when you look at the first half, second half, right? Method 1, do we include the median? The second one doesn't include, right? And the third one will be more systemic because we use a quantile function, right? So that will be the thing we will be using for our exercise, test, and assignment. The idea is interpolation, right? So we just the idea is exactly following from here, right? What is 1/4 of n+1 rank data? Okay, so that is how we do calculation. I'm not going to repeat that, but if you have any question related to this calculation, let me know. I can talk to you about that. But by doing the assignment, you will know how to handle those situations. And the next few things is related to variance. It's squared difference from the mean. Just to remind you that why we look at square is because you can definitely look at absolute deviation, which is more intuitive, but mathematical this square distance is more convenient, so that's why we use it. And there's one thing we learn is the sample counterpart. The sample counterpart, why you have 2 things here is this is the population version, is the thing we care, okay? But when you really, this one will be, you should use this one when you actually have all the things you need to know, right? Suppose the Hong Kong government want to know things and they have data for every single one, then you calculate variance, this is the thing you need, right? Suppose the Inland Revenue Department want to calculate the variance of income of everyone, right, in Hong Kong, and actually he has or she has the data, right? So that's why she can use this one. But if you just say you are a researcher or a firm who only able to get a subset of sample, in that case you will be using the sample counterpart, right? When you're trying to not looking at all the things that you want to do, but you want to use this as a measurement, you use this one, okay? And later, when you go to topic 5, we'll explain why this formula would make sense, okay? And do note that this one, right, n over n minus 1 is a number that bigger than 1, right? So that means that if you use the way that is do not adjust, right, this variance smaller, you have to adjust by a factor more than 1, okay? So that is what it means is if you try to use the formula that we're supposed to use for the whole population to the sample you're using, then you underestimate. So you have to adjust upward. Okay, so that's the idea. As I said, it's better to use, but explain later. Okay, it's not that bad, but some adjustment is better. Okay, so standard deviation is the square root of that, and just remind you that is to make sure the same measurement unit. And a related one is divided by sample mean. So just make sure that this useful is because of in this way it's not affected by the mean, right? Then, for example, you can compare, say, that's what you are doing when you go to take the exam, right? And you are trying to compare the case where one class have full mark 100, another case have full mark 50, and and compare the variance of two data sets, that's the way, because you don't want to be affected by the mean of the data, right? And the next two, probably this is something new to you, just is skewness and kurtosis, right? And why we care about skewness, as I said, is it showing that how the data is it symmetric or not, right? If the data symmetry is symmetric, then your skewness is 0. If right skew is positive, then it's left skew. So look at the graphic here. It's perfectly symmetric is 0, and the case where you have more of thing positive is called right skewed, and the other case is left skew. And you probably ask again why we care about this, right? And as I explained, if you look at the recent development in finance literature, stocks with positive skewness actually carry premium. People want to pay more for that. So that means the traditional risk-return trade-off is not the entire story, right? So it's risk-return, also skewness is also should be taken into account, right? And those stocks actually have positive skewness, you would be carrying more weight, right? Suppose you have see the stock, right? You expect have a positive skewness. It means that you can go up a lot, then probably you want to buy if the market hasn't taken that into account, right? And explain other business phenomenon and people behavior. And the other thing is if it's skewed, it means some classical way of handling things may not work very well. So it means that if you look at your data, when you do analysis, if the skew is very big or very small, or very positive or very negative, you should be more careful about your analysis. You require something non-standard analysis, okay? But that would be something important. And the next is just to remind you to when you do the adjustment, you calculate in this way, but you have adjust in this factor, okay? Again, you can see this more than one. Okay? That means that if you do this calculation, the skewness is underestimated in some sense, or in at least in the numerical value term. So the next is the kurtosis, okay? And just to remind you, you can see the kurtosis and skewness is almost the same formula, but here you raise to the power 4 here, okay? And you go back to see the skewness. The formula is just this one, right? Just wasted it 3 times, right? And look at the skewness. You can see this. The numerator is very same as the variance, but you have the raised to the power 3. Okay, and you divide this by the 3 times of SD, cubic SD. For skewness is because you want to avoid the problem of more spread and aspects normalized. Okay, of course, if you just care about positive and negative, it doesn't really matter that much because they just rescale, right? But if you want to compare across different data set, you divide by the cubic SD is a useful measure. Okay, and the kurtosis is like this, and again, because raised to the power 4, it must be positive, this number. Okay, and one interesting or one important measure is we look at excess kurtosis, which is U minus 3. And you ask why minus 3 is because 3 is normal. Okay, when the bell curve, the bell-shaped curve, the blue one, the bell curve is actually 3. So you want to see if this excess kurtosis is more than 3 or less than 3. Okay, if more than 3, then it's much more fatter tail. Okay, the tail is more fat. Okay, when the fat tail means what we're measuring is the catastrophic risk or event that is very unlikely. Okay, and when it is less than 3 or the excess kurtosis less than 0, that's thin tail. That means that extreme events are not very likely. Okay, so it's rather safe. Okay, you can see you can say the variance or standard deviation or coefficient of variation is measure of risk in general, and kurtosis is measuring risk in extreme value, right? It's not, one is measuring normal risk, one is measuring risk of extreme value, right? And the sample part is rather complicated. As you can see, this is a sample excess kurtosis. Some of you ask me, how do you calculate the sample kurtosis? Just add 3 to the end, because the difference between kurtosis and excess kurtosis is -3. So if you really want to measure the sample kurtosis, not the excess version, just add 3 to this formula, then you're done. But as we can see, we always interested in the excess kurtosis, so because we just care about whether positive or negative, right? Because it's more risk than normal or less than risk than normal is the criteria we are using, right? Because whether we are talking about catastrophic risk or extreme risk is likely or not, you just compare to some benchmark, and the benchmark is normal, right? So that's why this is the measure we're using. So this is all the calculation. I'm not going to talk about it, and I think we have enough motivation to study this already. But before we go ahead, is there any question? I think we just preview what we have done last week, but especially after the mid-autumn mooncake thing, probably the memory phase. So hopefully the memory comes back at this moment. Is that okay? If no question, then we'll finish the last section, and then we'll go to Excel. Okay, hopefully we'll finish all the slides for today. So so far we focus on measurement of single measure to look at all the income of all individuals, right? So every subject or every individual with one set of measure, but instead we have 2 sets of measures. Say X can be education, Y can be income, right? For person number 1, we have his income, his education, and so on and so forth until N guy. Okay. The question is, we want to know very often is the person who has higher education, do they have high income, or vice versa, right? So that is an important thing, right? So that's why you're sitting here instead of working, right? You are studying instead of working, right? You are forgoing the income that you earn from working. So there are 2 different measures. One is called covariance, okay? And it's together variance. So you can imagine that the formula is very similar to variance. That is a good guess. That's exactly what's going on. And covariance coefficient, as you can see, they will be similar to coefficient of variation, right? The same idea. So you see this as a normalization. But anyway, let's see the formula here. Okay. So the covariance is measuring the following. It's asking, is X and Y are moving in the same direction with respect to the mean. Okay. If X is above its mean X bar, is Y also above its mean? Okay. If they all the time above the mean together, below mean together, and they are positively related. If they below mean together, not together, right? One above, one below, one above, then is negative. So maybe let me use the describe something like this. So with a scatter plot here, X and Y, okay, and if the date we are going to draw a scatter plot, right? So for each observation, just put there in this two-dimensional graph. I hope everyone know how to plot this in the scatter plot here. So as you will see, if the data is look like this, okay, we know this is already they are positive related, right? Because this is something you will see this something like this, right? Okay, and you can see you can draw a line there to represent it. Of course, how to draw this line properly will be the goal of this class, right? At the very last topic, we'll tell you how to draw the line that fit the data best. That's the goal of this class. But now we want to know how to quantify the idea that they are move up together or move down together. The idea is following. So look at the dimension of x, the horizontal line. So this is x bar. Okay. Remember how we find x bar? X bar is located in the location that all the observations on the left, the sum of distance to the left to the sum of distance to the right. Okay. And you will also do the same for the another dimension, right? All of the y, right? Y bar, average of y, right? Forget about x, right? Will be somewhere here, okay? Somewhere here, okay? So you can see from this diagram, right? When x is above its mean, x bar, so it's all the observation that is on the left of x bar, okay? When it is on the left of x bar, it's above the y bar, right? So here, look at this, is when this is on this side, it's also on this side, right? And observations below x bar is also above y bar, right? So look at the data. If all the data are within this orange area, right? We'll call they are positive related, right? So that's why in calculation all the data here get you a positive number, right? If all the data appear in, I don't know what color to use, but green. All the color is here. The data is in here. The multiplication of them will be negative, right? Because what we care is, remember the formula is x minus x bar times y minus y bar, right? And you add them up and divide by n. Okay. When it's on the orange area, the first item is positive, the second item also positive, right? It's above. And it's in the bottom orange area the same, right? It's this negative is negative. Negative times negative positive, right? So when you in the orange area, then it's positive, right? When you in this green area, this is negative. Okay. So it's this covariance measuring whether the data is more likely in the orange area and then the green area. Is that clear what's going on here? Okay. So I hope that shouldn't be an issue. Then no, then we go back to the screen. Okay. So that is what we have is look at every observation minus the mean, okay, for x dimension and times the y dimension. Okay. The more likely that is in the orange area, it's more likely that it's positive. Okay. And it's divided by n. So this almost the same as the variance, right? But instead we have another y observation. Okay. And same here, the sample counterpart is also the same. It's just divided by n minus 1. This adjustment factor here. Okay. And now we also explain in the topic 5 why we have n minus 1. Okay. So covariance, later we'll do Excel, you will see we have a very population version and we have the sample version. Okay. The reason why we have the two again is we are always interested in this guy. Okay. Just to remind you again why we have this is we just this guy, but when you collect data and try to do analysis, then you cannot use this one. You have to use the below one because the below one is more accurate. Of course, using the above one is the crime? No, it's okay, but it's not as good as the below one. Okay, and that's why we use the below one. Of course, when n is very large, that these two doesn't make a difference. I mean, there will be very minor difference between you divided by n and n minus 1. Suppose you have more than 10,000 of observation, then usually you shouldn't be worried about which one to use. But anyway, so we come to the very last formula that we'll be talking is what we call correlation coefficient. Okay, so this one will be not complicated, just normalization. Again, because covariance, look at the previous formula, same as the problem of variance and SD, this measurement will have a unit. Okay, and it's difficult to tell the covariance is 1,000 or 2,000 or 3,000 can tell you anything. So that's why one very useful thing is you want to divide them by the SD of X and SD of Y. Okay. By doing so, one good thing is this value, which you can prove, is always between -1 to 1. Okay, this is called coefficient of correlation coefficient. Okay, so what it means is this normalization, this rescaling, it always gives you the value between 1 and -1, and 1 is when every dot is on a line, and -1 is every data point is on a negative line. So let me show you the example, and you will convince this is a good measure. So when you have this positive, right, and this negative, I think that is not very good because it looks the same. So positive should be something like, oh, I didn't know. I think that's be something like this, positive. More some, I think there's some more point here to say positive, and negative something more. There are more point here, but one is exactly the same point. Negative also the same. Sorry for the graphic, but that would be what it means. Maybe I draw it. Maybe I draw it here. I think so. So it'll be something like this. So X and Y. If all the data point is on a straight line, okay, then we will call this. We'll calculate over XY is exactly 1. If all the data point is on a straight line, in that case, rho XY is -1. And similarly, X and Y, if the points are like this, look at the positive trend, right? When it's above mean, then the line look like this, right? You can, if you want to draw a line that try to be best fit, right? And this will be rho XY bigger than 0. Why is the case? Because you try to look at this is the X bar, right? And you try to draw this, and this with the Y bar, okay? And you can see when X is above its mean, Y is likely above its mean. So this is more than 0, okay? And again, you try to draw X and Y. The dot is like this, okay? Rho XY is less than 0. Okay, and I'm not going to draw the mean, but I think one thing you would be interested in is what happened when you have 0, right? So let me. Is that okay? I go to the next figure. Okay. One thing is something worth mentioning is what happened when you have rho xy equal to 0. Okay. So it means that it's likely that everywhere the same. So one way to draw it is like this. Okay. In that case, you can see x bar is like here. Y bar is like here. Okay. In that case, the data is equally likely in this 4 area, right? So you can't really tell x and tell you x doesn't tell you anything y, right? So I tell you x is above his mean. It's hard to say. It's hard to say whether y is above the mean or below the mean. Okay. Remember, when they have 0 means that I tell you one is above the mean, right? It positive means it's more likely above the mean. If I cannot tell whether above the mean or below the mean, is hard, right? So I can tell you the data is above the mean on the right-hand side. Can you tell me whether it's above the y bar or below the y bar? Which one is more likely? You can't tell, right? Or I can tell you that y is above its mean. Is it going to be, for x, is it going to be less than the mean above the mean? You can't tell, okay? So that is one way that you have this equal to 0, okay? Of course, there are many ways you can generate the graph, but this means there are no linear relationship. Okay, so that's the idea. Sorry, I think there's I think I should. This graph is correct, but I think I should draw it less perfect to make the graph look interesting. Okay. Finally, one very interesting thing is there's no sample counterpart for this. The reason why is if you replace everything from sigma to the S version, okay, the same formula, okay. So one good thing about correlation coefficient is there's no need to consider sample. Sample the version same as the population one, which is kind of funny. Okay, so that's why when you look at the Excel later, you will see there's no sample version for this. Okay, the reason is because for all the calculation you divide by n-1, they cancel out, right? Same as before, because you can see here we don't have n here because everything is divided by n, they cancel out. Okay, you divide by n is this guy, right? You divide by n is this guy, divide by n by this guy. So there's no sample version for that. Okay. And last, we saw the example of this, how we do the calculations. Okay. Actually, we'll do this when we do Excel again, but let's try. So this will be something related to your assessment. Also, the assignment will give you some data and you do the calculation like this. So look at this data. We have a pair of data. First observation, x equal to 1 and 4, 2 and 7, 3 and 6, 4 and 4 and 5 and 9. Okay. So here I list in the form of table so that you can calculate easily, step by step, right? So first calculate the x minus own mean. You can see 1, 2, 3, 4, 5. The mean is 3. Okay. So minus 3 for each observation. Okay. And the mean of y is 6. Okay. So just subtract everything from 4. So from 6, you get the 4th column. Okay. And you multiply every row from the third column to the 4th column, you get the 5th column, right? Because the multiplication. Okay. And you multiply the 3rd column by itself, you get the second to last. You multiply itself for the 4th column, you get the last column. Okay. Now, then you add up everything. In the 5th column, you get 7. Everything in the second to last 10, and then last one is 18. Okay. In this way, you can calculate the population variance Why is 10? Because you have 5 observations. 10 divided by 5 is 2, right? And the sample version, you will divide instead of 5, instead 5 minus 1, 4, which is 2.5. Okay. And the population variance will be 18 divided by 5, which is 3.6. And then the sample version will divide by 4, which is 4.5. Okay. Now, finally, we calculate covariance and correlation coefficient. Covariance is rather simple, right? It's just this guy, 7, okay, minus how many of them? 5, right? If you divide it by n minus 1, which is 4, will give you the sample version. Okay. And the correlation coefficient, you can calculate 3 different ways. First, using the direct formula, using the 7, okay, over 10 times 18 in square root. So this is one way. How this formula comes about is coming from this formula directly. Okay. And you can also calculate using this formula because we calculate this already, covariance, ST and ST, or you can calculate it using the sample version. Okay. So this one is using the population version, 1.2 over square root of 2 times 3.6, 2 times 3.6. And the other is looking at the sample version, is 1.7 over square root of 2.5 times 4.5. So this is how you get this number. So this number is 0.5, okay? So it's more than 1, it's more than 0. So that means that it's just positive related, okay? Not small, not big, but it's good enough to say they move together, right? You can see 1, 2, 3, 4, 5. This is 4, 7, 6, 4, 9. Okay, almost fit into the moving together, except this guy is go up a little bit more than it should be. This one should be higher than it should be. Otherwise, it would be much nicer, but otherwise, it's okay. So the last thing is why we care about correlation coefficient or covariance. Okay, why we care about things move together. First is in finance, if you do investment, you want to invest in things that are not correlated. What we mean is what we call diversification, right? So if they move together, actually the risk will be higher. Okay, so that's why we would want, because if they are negatively correlated, means one going up, the one go down, right? So the overall, the variation will be much smaller, right? Because one go be up above the mean, one is below the mean. So most likely, if they cancel out or they partially cancel out, they will be more closer to the mean. So the risk will be much less. Okay, so that's why when you try to buy the market index, right, then you try to remove what we call the idiosyncratic risk, right, or the stock-specific risk. So that's why they are nice. And also that's why explain why there are a lot of people invest in startup, right? Because of startup unlikely to related to what happened in the market, right? And also people want to invest in cryptocurrency or gold, right? Gold is unlikely to related to the market movement, right? So these are the reason why we want to look at these things. Or people want to not invest in the developed financial market, right? Don't want to go to the US stock market. Sometimes they want to go to an emerging market, go to safe haven, right? The reason is the reduced risk. Okay, and that somehow explain why in the past 5 to 10 years, there are a lot of Chinese company go to list in the US and they got huge premium. One of the reason why is because they are relatively unrelated to US stock market. Okay, in that case, people find it more interesting, right? So that's why Chinese company also want to list in the US because of they can charge higher price. And why they charge higher price is because of the economy in the stock market in the US. The current stock will be most likely unrelated to what happened in China, right? So they enough separation to allow this direct circuit effect, right? So that's why some Chinese stock don't want to list in Hong Kong, because Hong Kong and China is so close to each other, so we don't have much direct circuit effect. Okay, and for the marketing, this something you want to know, right? Is sometimes you want to sell products, right? You just don't only want a guy to buy one product, right? Or they want to buy more, and you want to calculate correlation, whether one guy buy product A, one guy product B, then you want to put a discount on that as well, right? This kind of thing is how they're related and move together is very important, right? Because this is the basis of cause and effect, right? Here we just say about they move together, just correlation. We don't talk about causality. Not saying, say, having studied more in school, having higher income, right? But it do suggest those have higher income have more education, right? But it doesn't say one way or the other, right? It doesn't say maybe they're rich, they want to study more, right? We don't know which direction. If you want to infer direction, the causality, it requires things more than statistics, or require other evidence to support this. Maybe you have control experiment, right? You have two groups of agents, one group of people, you give them education, one group didn't, then you can tell. But without those kind of setup, you can't tell that much. But at least that will be the first way to show correlation, and then you can try to establish causality. Finally, want to have one slide that talk about investment, and because many people would be interested in investment, and what we learned from this topic, the class, we have many measurement, right? The first is central tendency, right? Mean and median. And what is the good stock? Good stock will be the thing with high mean and high median, right? That will be a better return. And you want the stock have low variance or low SD, which is less risky, right? And you want it to have a positive skewed, because you have a good chance of going up, right? Because all the stock that worse, they can go with zero, right? Positive skewness means that they can have a good surprise, right? One example of surprise may be Tesla, Google, all these stock have a good surprise. Okay, so that's why Tesla, people expect it's much more expensive than this would be, but because of people expect there will be much more supplies under Elon Musk, so that would actually carry a premium. Okay, suppose the unfortunate event Elon Musk say, I'm not going to deal with Tesla, I don't want to go to SpaceX only, then very likely that the Tesla price premium would reduce, because people expect he has exceptional skills that can boost the company. That is what is going on is skewness here, right? Because expect he's going to do exceptional thing. And kurtosis is you want the stock have low kurtosis, because you don't want catastrophic risk happen to that stock, right? If the stock just crazy like a roller coaster, go up and down crazily, then it's very risky, right? So that is the idea here. Okay, and maybe we have this slide before the break. Yep. So if you choose a stock here, we have three different stock, A, B, and C. Which stock you're going to choose? Okay, and first you would choose A over B, because they're same SD, but A has higher mean. And compare B to C, you would choose B over C, right? Because they're same mean, but B has low SD. And compare A and C, of course, you will choose A, because A have higher mean but low SD. Okay, same, you can do the kurtosis and the skewness. I'm not going to do it one by one, but you can see how you can choose stock using statistics. Of course, the problem would be something like this is one much more clear, right? But what happens if you're stock D? Okay, you have stock D, which has something like stock D that will require you to learn more finance, right? So suppose you have a mean of 10%, okay, but SD is like maybe 40%. Okay. Will you choose D or not? Okay. And it's not comparable. D, you cannot say A, B, and C is better than D or not, right? Because based on what we have, we can't tell. How to trade off this mean and SD will be the thing you learn in finance class, right? What we call is called the CAPM model, or what we call the three-factor model, or the model can tell you, is it a good trade-off or not? But that is not something we discuss today. If you learn finance, you learn how to choose that kind of trade-off. Right here is very straightforward, right? And very last thing, sorry, one minute over time. So just to say, if you have two portfolio, they have the same of everything. A good portfolio would expect you have zero or negative correlation among all the assets in and invest, because this means lower risk, right? So that's why we look at a good portfolio, right? If you want less risk, right, then you should try to look at the portfolio that combine different unrelated stock, right? Suppose a stock that actually focus on investing in Hong Kong, say Trackers Fund, it's okay, but may not be very good. Okay. And if your particular portfolio focus on only investing in real estate, and suppose you invest in Chinese real estate company, okay, in that case you are very happy in the past few years, but may not be happy starting from this year, right? Because the Chinese real estate company is not doing well. So you have a lot of risk, right? So that's why later when you learn finance, if you do, then you will tell you a good portfolio should have zero negative correlation, right? Try to have combined things that are not so related, right? So if you're in Hong Kong, probably your portfolio is related to Hong Kong, then you should invest things outside Hong Kong, right? So that's why recent years, a lot of people invest in US stock, right? Don't invest in Hong Kong because already your MPF, your stuff is already in Hong Kong. So invest in US or invest overseas if we're a good opportunity to diversify your portfolio. Okay, so let's have a break. These are the video links that you may want to look at if you forget what we talked about in the class. After the class, we talk about Excel. We'll be rather quick in Excel. But anyway, in the meantime, have a break. I will resume at 1:30. In the meantime, I just walk around to see if any question. We'll resume at 1:30. Right. Good. So the remaining time we'll look at the Excel. Some of you actually asked me the final test at the end of the semester. Well, it's too early, but I would say it's open notes, so you don't need to really worry about memorizing all the formula. You can bring as many things you want, but unfortunately, I cannot allow you to bring your laptop or the iPad in because of people said this. They can communicate with each other, so you can print whatever you like. Although I know it's not going to be environmental friendly, but either I allow you to bring or I don't allow. I think I allow you to bring is much more efficient because of you don't know. I don't want you to spend time memorizing formula that may not be used in the future. And all the time you can always have the formula available online anyway, right? So just when you go to the test at the end, you just bring it. And some of you worry about the test content. Probably later I will put on the past papers, then you will be much more relaxed. And I would say the final test will be very similar to the assignment. The assignment we ask will be also asked in the final test. Maybe some variation here or there, but we should expect some similar difficulties. If you understand the content material, then you shouldn't be a big issue for you. Okay. Now, Excel. So for those who are using the PC, would be no problem. Using the iPad, also no problem. If you really can't do it, we can use the Google Sheet. It's also not a big deal because we're not doing VBA. So that's why it's not a big issue. We're just using simple spreadsheet function. So it's not something big. Okay. So the function we mentioned should also be available, accessible using Google Sheet. Okay. Excel. So first, let's go ahead, try to use the Excel. I assume you have zero knowledge about Excel, so we start from the beginning. So in case you would not be, you think I'm too slow, let me know, but I just want to assume everyone have absolutely zero background. Okay. So here is a spreadsheet, okay, and looks a little bit crazy here and there, but I don't know whether you have ever looked in it. But what I do is I will go to the right hand corner to make it bigger, because that would make my eyes easy to see. Okay, maybe you are young, you don't have a problem, but when you get old like me, then I have to magnify a little bit. I look at my father, he magnified even bigger. Okay, so when you get older, you need a better magnifying glass. But anyway, here you can see this is a spreadsheet, and spreadsheet is two-dimensional one, right? So the column is A, B, C, D, E, and the row is 1, 2, 3, 4, 5. Okay, but the first thing we need to do is just double-click the first cell, double-click it, or if you use your iPad, you just click it. You can use even your phone can do it. Okay, if you don't want to have anything, use your phone. Just download the Office. I think you can access to the Office package from your phone or using the school ID and thing. Okay, so what we're going to do is we're going to start using is a calculator. Okay, so we can just press equal and do the simplest you can imagine, 1 + 1. Okay, and then you put enter, then already give you the 2. Okay, so that is the formula here. Okay, so we can use 3 - 1. Okay, so 2. Okay, so let me use one trick, what we call formula test. Okay, we'll talk about that later, but just showing you what I have input on the left hand side. Okay, so here is equal to 3 × 3, and this is equal to say 4 / 5. Okay, so this is how you do the plus minus. When you have the star, right, you have the times, and your slash will be division. And when you raise, I have this triangle is a raising to the power. Okay, so these are all the thing we need to learn. Okay, I hope that's okay. Is that okay, or anyone have any issue about inputting this in your Excel spreadsheet? Let me know. I can come over to see if any question, because it's more like tutorial style. So I just let me know. I go around if you have any question. Is that okay? No, just raise up your hand because you can consider this as a tutorial. I think we used to have this in the computer lab, but the computer lab is very difficult to book, and also have a limited capacity. So that's why this year we just do it here, because we just do Excel, we don't do R. So we do R, then probably we need to go there. But is there any question for this one? If no, then we go to the next one. Okay. So we are basically done with all this, right? Plus, minus, times, division, and raised to the power. Okay. And this is what we have here. Okay. This is the formula text here. This is how we do the calculation. And we learn square root and exponential. Work quickly. So what we learn here, square exponential, is what we call function. Okay. And in Excel, just this simplification is not enough. You need some more. What I learned is square root and exponential. Okay. Square root is SQRT. Okay. Square root. Take a square root. Then this is the function, and you have to write the function, and you have the input. The input will be enclosed by bracket 25. Then we'll give you 5. And then same exponential EXP raised to the power 2. Okay. We'll give you this number. So I hope now you see EXP is exponent. Exponent is natural log is 2.73 and raised to the power 2. Okay. So any question before I proceed to the next slide? So we just do step by step. Is there any question? If any question, let me know, because I want you can take out your phone and work on it, because it's important to work out yourself. I think your iPad or can work on it. Okay. I'm sorry for being very slow, but I hope being slow have benefit of everyone on the same page. Okay. Is there any question? If no, then we continue our journey to the next slide. We just go slide by slide. Okay. So that's count and sum. Okay. So that is important, starting from something important thing. Okay. So here for Excel, when you try to input your data, okay, you would be using a bracket, okay, and separate each data by a comma. So basically, it's just like this function is counting how many data you have here, okay, which is exactly the n in our formulas. Okay, so this is n, right? And the next one is sum, is summing all, right? And immediately from this, you can see how can we calculate average. Just the sum over the count. Okay, so let's try to do it here. Okay, we do a count, okay, and then we open bracket, okay, starting to do our function. Remember how we do Excel when we try to input data? Curly bracket, okay, curly bracket. We have to input all the data. So 1, 2, 3, 4, 5, and then close the curly bracket. Okay, the curly bracket implies this data set. Okay, and then you close the normal bracket. Okay, so this exactly tell you how many is n. N is 5. Okay, and then next thing is you can do it for counting the sum, which is the bracket 1, 2, 3, 4, 5, bracket closed. Okay, so this is sum, right? And easily you can say sum over count is average. right? What I meant is if you do it this, sum 1, 2, 3, 4, 5, okay? And divided by count 1, 2, 3, 4, and 5. Okay, this will give you what? Average, right? So this is exactly gives you the formula average. All right. So that's how you can use Excel to do this, right? So this is how you can use sum and count. Okay, these two functions. You can directly input the data in the function. Okay, that gives you the formula. Okay, so that is the good thing about Excel, right? Just you can input there. That's not a big deal. You can input as many data as you want. Okay, and here I'm not going to work it out with you for the round up and round down because I think from that on we become trivial, right? Round down and round up, right? Round down is just round down the number will give you the integer. Round up will give you the integer that at least as big as what you want. Okay, and the only thing I mentioned is here round down can be up to how many decimal places? There's a other variable called k. Okay, if you put 0 here, you just round up to the integer. That's what we mean. If you round up to 1, will be the first decimal places. Okay. Okay. So, but for our purpose, we will only always use 0 for our purpose. I don't think there's any issue there. Okay. I think this is already there. I'm not going to do one by one because I think that would be wasting time. So now the next thing I want to show is you Excel. This is the three thing we want to care, right? You're going to care about the mean, geometric mean, harmonic mean, right? That's why we talk about this, right? Average. Okay. Say here you can see the formula. You have to write this all. It's kind of clumsy, right? So the good thing is what happens if I can write average, okay? And bracket 1, 2, 3, 4, and 5. So if you do this, this will be the mean, okay? This is exactly the same number we expect to get. This is the mean, okay? And then you can change it to geo mean and harmonic mean. So you can have GEO mean, geometric mean, okay? And then again 1, 2, 3, 4, 5. Okay. You can also do the H mean, Har mean, harmonic mean. 1, 2, 3, 4, and 5. Okay. I'll stop here a little bit, go around to see if you're able to do it. But here you can see from Excel, you can quickly do all the calculation, right? So you don't really worry about the assignment, right? Because everything is, you can do Excel to check whether you do it right or wrong. And here is the first step we talk about Excel. So it's to calculate the mean. Therefore, of course, later we talk about median, right? And then so on and so forth. So to tell you Excel how to do all the calculation, okay? Although it's very tedious, maybe not very challenging, not very interesting, but I have to go one by one because I assume you have zero knowledge of Excel. For those who know Excel, then it will be very boring, but I'm sorry, but we have to make it the same for everyone. Any question? Everyone able to get it or not? Okay. If okay, let's talk about the next one. This one is what we call the weighted mean. Okay. The weighted mean, unfortunately, Excel don't have a function for that. Okay. You have to do it by yourself. Okay. And what I'm doing here is we will require what we call a function called sum product. Okay, sum product. Sum product means what? Sum product means you give him two lists. Okay, you will be multiplying the first item from the first list to the second item to the second list. So 1 times 6. Okay, and then you would do the same for the second element. You multiply the second element from the second list times this guy. Okay, okay, this is just a product, right? But you would add up the result. So it will be, what we get is 1 times 6 plus 2 times 3 plus 3 times 2 plus 4 times 3 plus 5 times 2. That's exactly what happened for the weighted mean, right? Each observation multiplies its own weight. Okay, and add together. And the denominator will be the sum of the weights, right? So that is exactly what is going on. Okay, so that is why we need to learn all this, is because Excel spreadsheet, unfortunately, don't have all the function you need. Okay, you have to create from the scratch. I mean, understand the formula and try to apply it. Okay, so let me show you how to do it. Okay, let's do sum product first. Okay, remember this one actually corresponds to the weighted mean here. Go back to, it's exactly this one. Remember this formula here? Exactly this guy. Okay, so what we do is sum product. Okay, and we input 1, 2, 3, 4, 5, and then would be 6. I forgot. 6, 3, 2, 3, 2, 6, 3, 2, 3, 2. Okay, so this will be the numerator, 40, right? So there's exactly what you expect to get looking at this one, right? The numerator is 40, right? And denominator is sum of the weights, right? Sum of the weights, we just this guy, right? Just do it at the end, divided by sum of the weights. Sum of the weights will be just 6, 3, 2, 3, 2. Okay, so it get what we want to get, right? Sum product, this multiplied divided by the sum. Okay, so this is exactly how you would be doing your Excel. Okay, is there any question? Is there any question? I just go around if you have any question, because is there any question? No? Okay, that's good. So the next will be median. Okay, median. So this is very simple. Median, just median. You just put 1, 2, 3, 4, 5. Okay. Automatically, the Excel gives you the median formula. Okay. Just you don't need to worry about that. Of course, you can write from scratch, but luckily you don't have to. The median is there already. Okay. And you may ask what's inside there. This median formula is within the Excel package, so it's written in the C language or C#. But that means that they will be very fast. Okay, so median. Okay, so you can see in this all the calculation here, we have to type in the data one by one, right? So it's not very convenient. Okay, so that we didn't use the useful thing about spreadsheet, because spreadsheet, what we need spreadsheet is calculation and data on the same page. Okay, that is one of the best benefit of using spreadsheet and one of the most drawback. Okay, when you present your idea or present a calculation, it's very simple because the data is on the spreadsheet and the calculation is on the spreadsheet. So that is a good thing, but also making your calculation more messier when you try to change it. Okay, it's not very transparent, but for simple calculation, it's rather quick. Okay, so what we learn is we need to learn what we call cell reference. Okay, and instead of directly put in the number, we put in data in the spreadsheet on some area, and when we calculate, we refer to that cell number. So as I mentioned here, right, every single cell you try to click will be referred by its column name and the row name, right? So this one is D1, this will be D2, and this will be C1, C2, right? So on and so forth. And you need to know what we call absolute address and relative address, okay? That will be one of the key things that differentiate basic user and more intermediate user, right? Is the use of the dollar sign here, okay? Okay. And turn out that if you add the dollar sign before it, because every single cell will be represented by a letter and a number, right? You can put a dollar sign A1, and you can put dollar whether you're dollar or not, right? And you put the dollar, it's absolute address. When you don't, we have relative address, okay? So you may ask, what's different between dollar sign and no dollar sign? Usually there's no difference, okay? The difference appears when you do copy and paste, okay? And that how to do copy and paste professionally will be very important skills, okay? For example, okay, looking at this example using cell reference, okay? And we have two data sets, 1, 2, 3, 4, 5, 5, 6, right? That's what the example is, okay? And we can say average from A2 colon A6 is A2 up to A6, okay? And we calculate the mean and same as median, okay? So let me show you the slide here. Maybe bigger, okay? Maybe data set 1, X1 can be 1, 2, 3, 4, 5, 6, okay? Make it center here, okay? And then we can calculate the mean, right? And the median, okay? And mean we call average, okay? And you can tell Excel where the data start, okay? Because our data start in a column form, okay? So just tell them the first upper cell, which is A2 here, okay? And then tell them the end. We use a colon, okay, to know them, okay, from A2 up to A7, okay? And then close the bracket. So this is same as inputting the curly bracket 1, 2, 3, 4, 5, 6, okay? There's one way to do it. Let me do the formula here. Okay, want to do it, okay? Maybe, okay? You can type it out, or you can look at this median, okay? A bracket here, okay? Now, instead of typing it out, use your mouse. If you're using or using your iPad also can do it. You can just use the mouse to click and drag, okay? Click and drag. And do the median, okay? And click and drag, okay? And then close it, the same thing, okay? So this is how, instead of typing the data, you can put data here and do click and drag, okay? That will be super useful, okay? Now, is there any question? I hope this can tell you how the separation of data and calculation, because the drawback of doing this here is you put the data in the formula, so difficult to see what's going on here. At least now, slight improvement is the data and the formula are separate a little bit, okay? Data is here, formula is there. then you don't need to worry about data here, right? Because when you change the data here, I change, say, 6 to 60, okay? Then things get changed directly, okay? So automatically updated. So that's a good thing about Excel. Also, of course, that's a bad thing, right? Because when you change it, then all the calculation in the spreadsheet will change, okay? Then can make things very slow. Okay, so I'm not going to fully replicate this, but I think it's very clear what's going on here. Okay, now maybe I can spend 4 minutes. Okay, let you do it. I talk about relative address. I didn't talk about that. Okay, so here I want to talk about what is a good thing about relative address. Okay, so suppose another set which is saying 5, 6, 7. Okay. Okay. I also want to calculate the mean of this column. Okay. So is there anything quick we can do it without doing all this thing, right? Because we already calculate mean and median for the first column, right? Can we come up with a smarter way instead of typing average again? The answer is what we call copy and paste. Okay. If you try to copy this and paste it here, okay, automatically you can see very nicely all the formula shift accordingly. Okay. But if you here, if I instead I don't allow it, I have an app, I put a $sign here. Okay, I put a $sign. Okay. In that case, if I do copy and I do paste, then nothing would change. Okay, that means that if I have things that remain unchanged, when I do copy and paste, I would do a $sign. Otherwise, if I want my formula change according to how I move, then I don't have the $sign here. Okay, and I think for the moment, I think it's sufficient enough. I will skip this because of time. Okay. And the other one I want to mention is define names, which also very useful. Okay. And let's see why it's useful. Define names is very similar to giving names to the data. Okay. So here, I call data here. Okay. So I have this data. I want to call it X1. Okay. So highlight them all. Look to the formula. Go to define name. Okay. Here they put X1 underscore. That's fine. Just call it underscore X1. Okay. Or maybe I don't like underscore. Can I do it? Oh, no, I cannot because X1 means something else. So X1 underscore. Okay. So in that case, I can do the following. Average of X1 underscore. Then the formula already know this is the case. The reason why you can call X1 because X1 already we refer to the cell X1. So I have X1 underscore. I have to name it this way. Okay. So this is how you can define things, right? You can use the same formula here. Okay. I hope that is clear how I do it. I just highlight the cell I want to call. Say this one again. I want to define name, and this is called X2 underscore because X2 has a other name there. Then I got mean of X2. Okay. And then I have average of X2 underscore here. Okay. And that is how you okay. That's how you can give the name to the data, because very often when you do the calculation for statistics, right? Basically you have 2 or 3 data sets, right? Just name them, then your formula will be much easier. Okay. So there are the tricks that can make your spreadsheet much more cleaner. But otherwise, it would be a useful trick. Okay. So now go to mode. Okay. We want to see, as I said, in Excel, if everything appear once, they will say no mode. Okay. And if appear more than one, they will just give you the most common one. Okay. So the MODE.SNGL. Okay. So, for example, I do a mode here. Okay. You go to MODE.SNGL, and because I use the name already, so I just use x1 underscore, be fine. Or if you don't like, I just do A2 up to A7. Maybe it is better. Do you understand? Okay. So you can, in that case, there's no mode, right? Because everyone appear once. Okay. So if I change this to 5, that's mode is here, right? If I change it to 4, you look at the smallest one. Okay. So this is a problem of Excel because it's a single mode. If you have 2 mode, they will pick up the the smallest one. Okay. But anyway, mode is not very you will use often, so it shouldn't be an issue. Okay. So in this example, you can see here, I'm not going to go to detail, but you have everyone appear once, then you'll see 1, right? There's nothing. But if appear twice, then you 2. If they're more than 1, then you choose the first one, the smaller one. Okay. So that is the mode. Okay. The next, so we finish all the central tendency. Then we want dispersion. Okay. Dispersion is biggest minus smallest, right? So max minus mean. So max gives you the max value. Mean gives you the smallest value. The difference is range, right? So maybe I get another sheet. Okay. X is what value? Maybe 1, 2, 3, 50. I don't know. Doesn't matter. Just a name here. Okay. Now we need to do the max and the mean, right? The difference will be range, right? The max will be just equal to maximum, and you just choose the data set, right? The max. Okay. And then very simply, the mean will be just the mean, right? The minimum of A2 up to A7. Okay. And then the range will be the max, which is C2 minus C3. Okay. So that's how you can calculate. This is how you do the range. All right. So it's very simple, right? Just, of course, you can put it in one single equation, right? You can do max of this minus mean of this. Is that okay? So any question? I mean, of course, I know this is very easy, but I cannot assume everyone knows Excel, so that's why I start from scratch. Okay. Now the next thing I want to show is the IQR, right? I think we go over the range and the IQR. So we so the quantile is rather easy. As I said, quantile many ways to do it. The way we do it in Excel, it will be the quantile exclude. Okay, that's a well quantile include, but it's another formula. But for purpose is quantile exclude, and quantile we have another thing. We have 1, 2, 3, 4, 0. 0 is the minimum. 1 is the Q1. 2 is the median. 3 is the Q3. 4 will be the maximum. Okay, minimum will be 0, right? So we need 1 and 3, Q1 and Q3. So it's quantile, this one, okay? So let's do it here. Q1, okay, Q1, Q2, we don't want the Q2, just this one will be fine. And then the IQR, okay? So will be quantile exclude. You can see there's a quantile include here, but we don't use it. It's not the one we taught in the class, okay? We quantile this guy, and then we use 1 to give you the quantile, first quantile, and then quantile of this guy, 3, it will give you the first quantile, and then you just subtract this from this one, that gives you the interquartile range. Okay, I hope that is intuitive enough. Is that clear? I hope that is nothing deep here, but just you need to know this is a formula to calculate, and you put 1 and 3 for Q1 and Q3, and there's nothing deep. Of course, you can put this minus this and then once and for all, but I think that's fine. Okay. Now the next thing I think we do IQR we done already. So box plot, I think I can just show it quickly. So box plot will be, we need to plot in the Excel. So very simple. Insert here, highlight the data you want to plot, okay? And go to recommend chart, okay? And usually they'll give you the thing you want, but in this case not the all chart. And go to box and whisker, okay? This gives you the answer. It's okay, then that's it. Okay, so you can just click OK, and looks very big, but maybe I make it smaller because doesn't seems to be a okay. Then this one looks better. So this is the box plot, right? This is the minimum, this is maximum, and Q2, Q3, Q1. Okay, so this is the box chart. I think you don't have any problem plotting this chart by yourself. Okay. And then the next thing I want to talk about variance. Okay. So as I mentioned, you have 2 formulas here. Variance.P, population 1, variance.X. Okay. .P is the one divided by n. .S is the thing you use, is divided by n minus 1. Okay. So you can see this is divided by n divided by n minus 1. Okay. So let me do another slide again. X 1, 2, 3, 4, 5. Okay. So what I want is variance dot P and variance dot S. Okay. So what I'm going to do is to do like variance dot P. Okay. This one is exactly divided by n. Okay. So we highlight them all. Okay. This one, enter, will give you the one that's divided by n. Okay. And S will be divided by n minus 1. Okay. So you have variance P and variance S. Okay. Then again, you have the standard deviation. It's called STDEV, same thing. Okay. So STDEV, standard deviation P, population, standard deviation S. Okay. It's the square root of what we have. Okay. So STDEV dot P, STDEV dot S. Okay. P is here, and STDEV.S is here. Okay. So this is the formula. Okay. And you can see you take a square root of this will give you the same, will give you this thing, right? So if you take SQRT of this guy, okay, exactly it's what you want, right? So the square root, right? Square root of this guy. Okay. So the next thing is to calculate the coefficient of variation, right? Which there's no formula here. So how can we do? Okay. Let's do here is called CVP and CVS. Coefficient of variation P, coefficient of variation S, right? So that's not hard. Coefficient of variation just is the standard deviation over the mean, right? So you'll be doing STDEV.P, this guy, over the average, okay, of this guy. And remember, usually we times 100. Okay, so this is the coefficient of variation for this one. And you want the sample version will be STDEV.S, okay, of this guy over the average of this whole thing and times 100. Okay, so this is how you do the CV, population one and the sample one. Okay, so that is how Excel did it. Is that okay? Okay. Lastly, I want to show kurtosis and skewness. Okay. So skewness have two versions, population and sample. Okay. And kurtosis only have the sample version. Okay. As we do this sample excess kurtosis. Okay. So let me open another one. Okay. X 1, 2, 3, 4, 5. Okay. So we will do three things here. We will do skew. Okay. And we'll do skew sample. And we'll do sample excess kurtosis. Okay. So skewness will be just skew and put it there. This will be the skew. Okay. You can easily see the skew should be 0 because it's a metric, right? And you can easily check if I change it to 50, the skew will be very large, right? And the sample version will be the skew. Sorry. They do this, not P. S is the one with the S. So SKEW.P. So this is sample skewness, and the sample one has no dot. Okay, I don't know why they do it, but this is how they do it. So you can see the sample one will be higher than the population one, as we have said in the class, right? Because that one is underestimated skew. And in that case, without the kurtosis, it's just QURT, curve. Okay. And this is, remember, this is sample excess kurtosis. Okay. So when you have 4 here, it's very large, right? The benchmark is 0. Okay. So if I put this 50 to become 5, I should expect negative, right? Because it's more condensed in the middle rather than the bell, as I explained in the class, right? Because everything is within 2 SD, 1/5. Okay. So so that's the kurtosis. Okay. So that's pretty much of here. Maybe there's some scatter plot or correlation. We'll talk about the next class because time's up. But We almost finished this one, and then we will start the topic 2 in the next class. Okay. We'll see you on Thursday.